let's practice some hypothesis testing. So in the first exercise here, a brand of children's juice boxes is labeled as containing 80% real fruit juice. A consumer group believes that the proportion is actually lower. So the first thing we need to do is we need to identify the parameter of interest. What are we actually trying to write hypotheses about? So in this case, you're seeing it right here. We're talking about the proportion. And we knew it back here also when we noticed that they were talking about percentages. Remember that your proportion, percentages, even probabilities, you're all talking about the same thing. Another thing to notice is that this is categorical data. So we're looking at the proportion of fruit juice in the juice boxes. So let's define that parameter of interest. We're going to use P as a representation for proportion in this class, and it's going to represent the percent of real fruit juice in all the juice boxes of that brand. Remember, this is our population proportion that we're talking about here. And then we need to write the null and alternative hypotheses. And you can see here that they believe the proportion is actually lower. So our alternate hypothesis would be that P, the proportion of real fruit juice in all their juice boxes, is less than that 80%. When we write the hypotheses, you want to switch to writing in proportions instead of percentages like this. And then our null hypothesis always has our statement of equality, so it'll be P equals 0.80, like so. All right, and then looking at that alternative hypothesis, which we came at because it was lower, tells us that this is going to be a left-tailed test. So our picture would look something like this, and we're looking at the lower tail for evidence against that. All right, for this problem, let's do the following. It says, suppose the consumer group examines a sample of the juice, which leads them to reject the null hypothesis. Write a conclusion for the hypothesis test. So say we went through the test, found our p-value, and we decided we were going to reject the null hypothesis, which means we find support for the alternate hypothesis. Let's write this. When you're writing conclusions for hypothesis tests, make sure it's in complete sentences. So let's say something like this. The sample data, which we don't have for this problem, we're saying whatever it was led us to reject. Okay, so the sample data provide evidence that the percentage of real fruit juice in the brand's juice boxes is less than 80%. So we found support for the alternate hypothesis. In this case, that hypothesis was that that proportion of real fruit juice is less than 80%. Okay, well, sometimes due to our sample data, that actually is an error. Our conclusions from our hypothesis tests could be mistakes. So suppose, in fact, that the labeling is accurate and we just had sample data that led us to the other conclusion. Is this a type 1 or type 2 error? So if the labeling is accurate, then the boxes really are 80% fruit juice, real fruit juice. So when we make the error of rejecting a true null hypothesis, that's a type 1 error. So the error of rejecting the null hypothesis and deciding that the percentage of real fruit juice is under 80% when really it is 80% is a type 1 error. Okay, let's try one more. So this exercise says that the U.S. Small Business Administration developed a program encouraging Americans to eat a higher percentage of their meals at restaurants. Prior to the program, 21% of caloric intake in America was consumed at restaurants. So how would we set this up? Let's start by defining the parameter of interest. Again, we're talking about percentages, so we're going to use P, our population proportion, for our parameter. And then you want to write down what is it representing. So in this case, it's representing the proportion of calories consumed at restaurants. By Americans. You can always find those statements in the problem statement, like where did they define what they're talking about. In this case, they were talking about the percentage of caloric intake in America, so I could have phrased it that way also. All right, let's try and write our hypotheses. We know our parameter is P, so that goes here and here. We know the null hypothesis always has a statement of equality. And then let's look back at our problem here. In this case, it says prior to the program, 21% of caloric intake in America was consumed at restaurants. So we're starting with a 0.21 for our proportion. And then they're saying that they're trying to encourage them to eat a higher proportion, or higher percentage. So we're going to investigate whether this proportion is actually now larger than the 0.21. So it's higher. Our alternate hypothesis is a greater than. We're looking at a right-tailed test. When we carry out a hypothesis test, we'll be looking for evidence in that upper tail. Okay, so suppose data from randomly selected Americans does not provide enough evidence to conclude that the business program was effective. Stop right there. What does that mean? It means we didn't find evidence in support of the alternate hypothesis, so we would have concluded that there's no evidence against the null hypothesis here. It says provide a valid statement that could be put out by the U.S. Small Business Administration. So what would you claim? You could say a lot of different things here. Here's what I did. I said, unfortunately, we do not have statistical evidence to indicate that the program to encourage Americans to eat a higher percentage of their meals at restaurants was effective. All right, something like that. So our data didn't lead us to conclude that the program was effective. All right, and then last one here, suppose in fact that the percentage of meals eaten in restaurants has increased. See what we just did there? So what if really the alternate hypothesis was true? Then has a type 1 or a type 2 error been made by the U.S. Small Business Administration? Yeah, so if the percentage of caloric intake at restaurants has actually increased, then the alternative hypothesis is true. And when we make the error of failing to reject a false null hypothesis, we've committed a type 2 error. So the error of failing to reject the null hypothesis and deciding that the program was not effective, when really it was effective and the percentage of meals at restaurants has increased, that is a type 2 error.